Hello everyone, let us solve some problems on the basic concept, that is from module 1. In that, first question is determine V2 minus V1 for the following network. This is the given network. He is asking V2 minus V1. First to draw the circuit for V1 to V2. First to draw the network for V1 to V2. So this is V1 and here it is 2 ohm resistor. And this is 5 volt source. Next one, this is 3 ohms and this is V2. This is 2 1, 5 volts, 3 ohms. Okay, this can be drawn as, this is V1 means the source is like this. This is V1 and it is ground. It is V2 means source is like this. This is V2 and it is ground. So if you apply KVL, this is KVL. Let it be VA, let it be VB. If you apply KVL, what you are getting? So minus V2 plus VA plus 5 plus VB plus V1 is equal to 0. From this, what you are getting? V2 minus V1 is equal to VA plus VB plus 5. Now we want to find out VA and VB. So what is VA? VA means voltage across 3 ohm resistor. So what is the direction? This plus is connected to this plus. That means this is positive, this is negative. Here this minus is connected to this plus. So here it is minus and this is plus. So it is V. Let it be loop current I1 and let it be loop current I2. Write the mesh equation for loop A or loop 1. You can take it as loop A. For loop A. So what you are getting here, the current is leaving the source, that is current is leaving the positive terminal of the source. So in mesh analysis we are taking it as positive, plus 8 is equal to, this is 6I1 and this is 2I1. It is not associated with any other loops, so we are getting directly this I1. So from this, what you are getting, I1 is equal to 1 amp. Current is entered positive terminal of this resistance. So what is VA? VA is equal to 2I1. So 2 into 1, 2 volts. Now coming to this loop, let it be loop B. Write the mesh equation for loop B. Write the mesh equation for loop B. What we are getting? Here also current is leaving the positive terminal of voltage source. So it is 12 is equal to 6I2 plus 3I3. I2. 6I2 plus 3I2. From this, I2 is 12 by 9. That is 4 by 3 amperes. Now what is VA? What is VB? VB is equal to, this is VB. Okay, this is plus, this is minus. Sorry, this is VB and this is VA. This is VB, this is VA. So here it is VB. Now, so we want to find out VA. So what is VA? Here current is leaving the positive terminal. This is a passive element. So in passive element, current must enter at positive terminal, but here current is leaving the positive terminal. So the voltage VA is 3 into minus I2. So you will get 3 into minus 4 by 3. This is minus 4 volts. From this equation 1, from 1. So what is V2 minus V1? V2 minus V1 is equal to VA. So VA is minus 4 volts plus, what is VB? We got 2 volts here. So this is 2, this is VB, not V. plus 5. So you will get 3 volts. Next question is find I in the following figure. Okay, this is the given network. See here they are asking find current I. So from this, what is current I? I is equal to, by Ohm's law, this is voltage. This resistance and this resistance are connected in series. So voltage by current 5 VAB by 2 plus 3, that is equal to 5 VAB by 5. I is equal to VAB. So what is our ultimate aim? We need to find VAB. VAB means this is VA, that is point A, and this is node A, this is node B. So VAB means this is plus minus VAB. Here the node voltage is mentioned as VA. VA means from here to here. This is reference node. From here to here, the node voltage is VA. So this is plus. Here to here, this is plus, this is minus VB. Now, these two resistors are connected in series and across 9 volt source. These two resistors are connected in series across 9 volt source. So we can apply voltage division rule. So by voltage division rule, what is VA? VA is equal to, by voltage division rule, VA is equal to same resistance by total resistance into total voltage. So if you solve this, you will get VA is equal to 4.5 volts. Similarly, same, these two resistors are connected across these 5 VAB dependent voltage source. This is dependent voltage source. So these two resistors are connected across, these two resistors are connected in series as well as connected across 5 VAB dependent voltage source. So by voltage division rule, what is VB? VB is equal to same resistance by total resistance into total voltage. So this is VB is equal to 2 VAB. Now apply KVL for this loop. Apply KVL for this loop. So what we are getting? So if current is taken as like this, so here current is leaving the positive terminal of VA. So let it be minus VA. Now this is plus VAB. Sorry. Here current is entered positive terminal of VAB. So it is plus VAB. Next, plus here also current is entered positive terminal of VB. So it is VB is equal to 0. From this, what is VAB? VAB is equal to VA minus VB. From this expression, what is VB? VB is 2 VAB. So substitute here, VAB is equal to VA minus 2 VAB. We know that VA is 4.5 volts. So this is 3 VAB is equal to 4.5 volts. From this, VAB is equal to 1.5 volts. So we know that I is equal to VAB. So what is current now? I is equal to VAB, that is equal to 1.5 amps. In the next video, we will discuss some more problems on this concept. Thank you for watching.